Hello, good morning. I'm Sudarshan Nayak. Today here present next topic about next more detail about fridge. We know about that the refraction through the denser medium. If the denser medium is very high refractive index, you may say that diamond, rutile, so many things are glittering object, that is refractive index is more than 2. So here is refractive index 2.42, that is the diamond. Now let's study about diamond. When the light passing through the denser medium of diamond, which refractive index is 2.42, then what is the velocity through the diamond? What is the value of velocity of light through the denser medium? So first of all, this one, okay, here is we know that the refractive index of the diamond, that is mu d. Okay, this is the value of velocity of light through the vacuum. Velocity of light through the diamond. Diamond is the material, just difference from the rarer or vacuum, because we have to just difference from the rarer or vacuum through the denser medium, that is diamond. Okay, so this is the velocity of light through the vacuum, that is C, and its value is 3 into 10 to the power 8 meter per second. And the velocity of the light through the medium, that is diamond, we have to find out the value of velocity through the diamond. So velocity of diamond, we know here, we clean this one. This is the refractive index of the diamond, that is 2.42. So we put the value of refractive index of the diamond 2.42. So here we put the 2.42. Now we have to find out the value of velocity through the diamond. So let this one brought left side, this is G, and the velocity 3 into 10 to the power 8 meter per second, and this is 2.42. The refractive index of any material, either it is rarer or it is denser, there is something value and have no unit. So there is no unit, unitless. So we calculate this one, that is 3 into 10 to the power 8, and this is 2.42, and okay, 300 into 242, 10 to the power 8. Okay, when remove out the point, okay, when it's shifted to the right direction, that is, what is this 2.42, when shifted to right side, then we can 242.0. the point is shifted here after 2 digit right side, then it is 10 to the power minus 2, and when 10 to the power minus 2 brought nominated part upper side, then it will be positive. So here is positive, so you can say that this is 10 to the power plus 2, and when we multiply this one, then will be 300. So here is 300 by 242 into 10 to the power 8. Now we calculate this one. So this is we use the calculator, 1 point something value. Here is calculator. Suppose that let me bring the calculator. So let calculate this one. This one is calculator. Okay, so we find out the value of calculator, accurate value. That will be accurate value, that is 300 divided by 242. What is that? Is 2.23967. So here is the value is after simplify this one, it will be 1.23967 into 10 to the power 8 meter per second. Now this one is this, like this. You can say that approximate value, that is approximate value, that is approximate 1.24 into 10 to the power 8 meter per second. This is the velocity. This is the velocity of light through the denser medium, that is diamond. When the light travel through this one, then the velocity of light, that is normal, that is suppose that this is the normal. So this is the normal incident or the velocity of light. This is 1.24 into 10 to the power 8 meter per second. Here is the just difference. That is, here is just difference from the vacuum. Vacuum is 3 into 10 to the power 8 meter per second, and it may be said that there is 3 lakh kilometer per second, whereas it is 1.24 into 10 to the power 8 meter 0.8 meter per second. It may be write this one 124,000 kilometer per second. Here is meter, that is meter. You may write this one more simplify this as 2.42 into 10 to the power 5 into 10 to the power 3 meter, and this 10 to the power 3 meter is known as 1 kilometer. When we converted 10 to the power 3 meter equal to 1 kilometer. So here is this one is this is kilometer, 1.24 into 10 to the power 5 kilometer per second, and this is we can write in simplest form, that is 1,24,000 kilometer per second. It is lesser than the refractive index of the glass. Glass has a refractive index. This is the velocity of the diamond. Velocity of light through the diamond. And velocity of the light through the vacuum. Velocity of light through the vacuum. Velocity of the light through the rare medium, that is air. Also same thing, this is equal to the velocity of light through the air, vacuum, and this is the diamond. Just difference, it is the reason behind it. Let's go through it. When the light travel or passes rarer to denser or denser to rarer, in this case the refraction takes place. Whenever the refraction takes place, there is the scattering of the light. The Rayleigh scattering is implemented here. So clean this one, rub this one, then we actual meaning, that is the what is the actual phenomena when the light travel from rarer to denser medium. Then the light bend toward the normal, that is the bend toward the normal. So let's go through detail. So already you know that the refractive index on any transparent medium, greater the refractive index, greater the glittering. And when the greater the refractive index, that is the velocity of light lesser than the velocity of vacuum. Respect to it is depend upon the refractive index of the light, refractive index of the transparent medium. Okay. Here is this is the triangular shape prism. This is place that is placed on the table here. This is the prism. There are two phases. That is the first reflecting surface and another is the second. If the light is passing through here, passing from this side, when the light is passing through the left side, then the reflecting surface is this one is first and this one will be second. So the light is passing from my left side. So light is passing here, light is pass. When the light incident on the first surface of the prism, then it is a incident point. Here is called incident point, and we draw a normal on the surface. That is, this is called surface. Okay, when the perpendicular draw this one, this is called normal. Now this is called normal. So we draw the normal here. This is normal. This is 90 degree. This is normal and dash. This is angle of incident. When the light travel through the rarer to denser medium, in this case here the incident point and normal making incident ray and normal makes an angle. That angle is called incident angle. So it is represented by I, and it is always greater than the refracted angle through the denser medium, because it is the light is traveling from the rarer medium, so its angle will be greater than the refractive angle of the denser medium of the prism. So here is, this one is reflected ray through the denser medium, and if it is the refractive index is 1.5, then its velocity is 2 into 10 to the power 8 meter per second, whereas the comparison with here, that is this velocity is 3 into 10 to the power 8 meter per second. If here is diamond, if diamond is placed in place of prism, then its velocity will be this one, that is this one. This is the velocity of diamond. Suppose if you a diamond is taken and its refractive index is 2.42, so many glittering diamond is so many glitter in throughout the world, because it's a refractive index and there is a critical angle. So due to critical and refractive index greater and lesser the critical angle, and greater the refractive index. In this case, the diamond is glittering so spectacular. So diamond is spectacular glittering things we use in our ornament. Okay, so this one is the, okay, let it go. And this is the refractive index of the glass and the velocity of the light through the glass medium, that is called 2 into 10 to the power 8 meter per second. Then here is R. Here is R. This is the reflected ray, and when the light is passes through the denser medium, then here also the second surface strike, and here after striking the second surface of the reflected ray of the first surface, reflected ray, and this reflected ray incident on this point, this is another point, we naming this one, this is P, Q, R, and this is the normal. In the normal N2, this is N1, okay, and here is N1, N2 dash. So here is normal. So here is normal. The normal is like this. This is the normal. This is the normal. Okay, this is normal. This is not normal. Okay, normal is here. Here is normal. Here is normal. Here is 90 degree. Here is 90 degree. And this kit, we know that the refraction takes place when the light travels through the denser to rarer medium. In this case, the refracted ray after inciding from denser to rarer, after the rays is passes or traveling through the denser to rarer medium. In this case, the refracted ray away from the normal. And in this case, the incident ray is less than the refracted ray. So here is R2 and here is R1. R2 is taken due to the second surface of the prism, and R1 is taken, it is the angle of refracted ray on the second surface of the prism. So here is the travel emergent from the second surface from the prism, that is like this, and this is called emergent angle. After the phenomenon of this one, the light incident on the first surface travel through the denser medium, and then thereafter is emergent from the second surface. In this phenomenon, there is the refraction. There are two surfaces, so the refraction will be 2 times. Refraction takes place 2 times, first surface and second surface, and after that, whole phenomenon, throughout the phenomenon, there is the refraction takes place through the prism, and here, like this, light is the combination of 7 color, that is the spectrum, and 7 color, that is the visible light, that is a spectrum band between 400 nanometer to 700 nanometer. So here is like this, that is called red, and this is called visual. That is V0, and this is called least, or this is called most. Deviation, because this the deviation is takes place. Here is deviation. Here is deviation. Here is deviation. Here is the least deviation. This is called the deviation angle of red color, and this is called deviation angle of violet color. And the between deviation angle of violet color is greater than the deviation angle of red color. So the difference between D minus this is angular displacement. Angular displacement is the just difference between the minimum deviation of violet color and minimum deviation of red color. The angle make, this angle is make. This is called the difference. This is the difference. This is the difference. This is the difference. Okay. This one is called the. This one is. Okay. This angle is called the angular displacement. So this angular displacement is formed between the extreme color of the color band. This is the 7 color band. 7 color band. This is called a spectrum of white light after passing through the denser medium. A spectrum through the white light. Okay. So here is here you know that this is the normal. Okay, this is the normal, and this is the original path. This is the original path of the incident ray. Original path of the incident ray when the light incident on the first surface. The incident ray. And it deviates toward the normal like this. This is the deviate, this is the angle, and this is the normal, and normal angle is the R1 is the angle of reflected on the first surface, and this is the dispersion. Here is the dispersion of light. When the dispersion of light, the dispersing power of the color depend on the photon energy and wavelength. If the photon energy is greater and wavelength is lesser and frequency is greater, in this case the scattering power greater. If provided that there is less scattering, it is depend upon the frequency, wavelength and energy of photon. If the energy of photon is less, frequency is high, and frequency is less, wavelength is high, wavelength is high and frequency is less, and the here is red color. This is the least deviation. This is the red color least deviation. Red color deviation. In the red color deviation, there will be the minimum deviation. The region is here. The photon energy of red color 1.78 electron volt. Wavelength of red color is called 700 nanometer. 700 nanometer. And this case here is the photon energy of the violet color, that is 3.11. Okay, electron volt, and wavelength of the violet color, that is 400 nanometer. So this is let me just, this is the natural light. This is the time is here is just 8 o'clock, nearby about 8 o'clock. So the light, natural light is just below the whiteboard. Sun is rising, then the angle is just this, like this one. This is the window. When the sun is upward, then when the sun is at the center point, then whole area would bright light. When the sun is here, the particular point, when the sun is here, then the light goes downward direction. So there is something darkness. The percentage of photon is greater lower side of the whiteboard, and greater lesser is upper side. So let it go. So now this is the angle of this one is the least deviation due to, and this is the higher, this is the low frequency, this is the low frequency, and this is the high frequency. If the frequency is high, if the frequency is high, the vibrating is most. When the vibrating is most, it scatters high according to Rayleigh area. According to Rayleigh scattering, it is 1 by lambda 4. Scattering is very high according to Rayleigh criteria. So today is enough. Next day I will teach about more detailed like research. So thank you. Goodbye.